let us consider this topic, this variation. So under variation, we're going to look at direct variation, inverse variation, joint variation, and partial variation. So we're going to start with direct variation. So in direct variation, when you are given two quantities, when one quantity increases, the other one increases uniformly. So the graph under direct variation is a straight line, maybe distance over distance against time. The graph should be straight from the origin. So this graph shows that distance varies directly to time, because it is from zero, from the origin. It's a straight line. That means when time increases, distance also increases. When time decreases, distance also decreases. So let's see this example. A quantity E varies directly as M. Find the law connecting the two. So we are going to use the sign of proportionality before introducing the equal sign. After introducing the equal sign, we introduce the constant. So here we say a quantity E varies directly as M. So we use the sign of proportionality before using the equal sign. So that we say E is equals to, so when you introduce the equal sign, you introduce the constant. So here we'll say E is equals to Km. So that is the law connecting the two. So let's look at example 2. A quantity C varies directly as D. A quantity C varies directly as D. You must use the sign of proportionality before introducing an equal sign. Then when you introduce the equal sign, you introduce a constant. So C is equals to, say, Kd. Then K is the constant of proportionality. So you are told C is equals to 21, D is equals to 7. So 21 is equals to 7K. You need to get the value of K. Divide 7, divide 7. So K is equals to 3. So you rewrite the law, that is C is equals to K, but K is 3. That is 3D. That is the law connecting the two. Then find C when D is 28. So C is equals to 3 times 28. C is equals to, that is 3 times 8, that is 24. That is 2. 3 times 2, that is 6, that is 84. So C is equals to 84. So this is inverse variation. So in inverse variation, when given two quantities, when one quantity increases, the other one decreases. So in inverse variation, we have two types of graphs. So the first one, we have distance against time. So the graph, that is how the graph of inverse variation looks like. That is the first graph. Because when distance increases, time decreases. When time decreases, distance increases. Then the other graph is a graph of distance against inverse of time. That one is a straight line from the origin. That's the second graph. So there are the two graphs that represents inverse variation. The first graph is distance against time. Then the second graph is distance against inverse of time. So distance against inverse of time is a straight line from the origin. Those are two types of graph under inverse variation. So when you have this example, is that the quantity L varies inversely as W. If L is 10 when W is 4, then find L when W is 5. A quantity L varies inversely as W. So inversely means 1 over W. So L varies inversely as W. Then introduce equal sign. If we introduce equal sign, introduce constant of proportionality. So L is equals to K over W. So that is the law connecting the two. Then we are told L is 10 when W is 4. So L is 10 is equals to K over W. W is 4. Multiply by 4, multiply by 4. So K is equals to 10 times 4, that is 40. Then we get the value of L when W is 5. So L is equals to K, which is 40 over W. That is the law connecting the two. So we'll say L is equals to 40 over, that is 5. L is equals to 8. It says, it's given that P varies inversely as Q. P varies inversely as Q. Then, when Q is 3, P is 1 over 6. So you need to do this first. P varies inversely as Q. So introduce the equal sign. P is equals to K over Q. When you introduce the equal sign, we introduce the constant of proportionality. So we say P is equals to K over Q. Then when Q is equals to 3, P is equals to 1 over 6. So we say 1 over 6 is equals to K over 1 over 3. Then multiply by 3, multiply by 3. 3 here 1, 3 here 2. So K is equals to half. We say P is equals to a half over Q. Then we need to get the value of P when Q is 9. So P is equals to a half over 9. That is P is equals to a half divided by 9. So we change this one, that is P is equals to a half times 1 over 9. So we get that P is equals to 1 over 18. That's the value of P. So in joint variation, this is an example of a formula. This interest is equals to principal times rate times time over 100. So here we can say that interest jointly varies as P, R, and T. Interest jointly varies as P, R, and T. So let's see the example. P varies jointly as Q and R. P varies jointly as Q and R. So we are still using the sign of proportionality. So P is equals to KQR. When you introduce equal sign, you introduce constant of proportionality. So we are given P is equals to 18 when Q is equals to 3 and R is equals to 2. So P is equals to 18 is equals to Q is equals to 3 times R is equals to 2 then times K. So 18 is equals to 3 times 2, that is 6K. Divide 6, divide 6. So we get K is equals to 3. But we are told to find R when P is equals to 54. So if K is equals to 3, we will say P is equals to 3QR. That is the law connecting them. Then P is equals to 54. So 54 is equals to 3 times Q is 9, times R. So 54 is equals to 3 times 9, it is 27 R. Divide 27, divide 27. R is equals to 2. That's the value of R. Let's see partial variation. So we have an example here. A variable y is partly constant and partly varies as x. A variable y is partly constant and partly varies as x. If x is 2, y is 7, and when x is 4, y is 11. We find the equation connecting the two. So a variable y is partly constant. When you are told that a variable is partly constant, that means that you introduce a constant, then a variable y is partly constant and partly varies as x, so plus x. So you remove the sign of proportionality, equal sign is equals to a plus, then you introduce here a constant, that is kx. So y is equals to a plus kx. You use any letter to represent a constant, any letter of your choice. So we are told if x is 2, then y is equals to 7. And when x is 4, y is equals to 11. So we say 7 is equals to a plus x, that is 2k. That is equation 1. Then equation 2, 11 is equals to a plus 4k. Then we use simultaneous, these are simultaneous equations. We use elimination method. So we eliminate a. That is 2k minus 4k, that is negative 2k. Then 7 minus 11, that is negative 4. So negative 4 is equals to negative 2k. Divide by negative 2, divide by negative 2. K is equals to 2. Then you need to get also the value of a. After getting the value of k, so we use a of the 2. At 7 is equals to a plus 2k. K is 2, that is plus 4, that is 2 times 2. Then 4 comes to the other side, that is 7 minus 4. So a is equals to 3. So the equation connecting the two will be y is equals to 3 plus k is 2, that is 2x. That is the equation connecting the two. So let's see the second example. The question says that y varies partly as x and partly as x squared. When x is 2, y is 14, and when x is 5, y is 65. Express y in terms of x. So we are told y varies partly as x, y varies partly as x, and partly as x squared. So you see that this question is a big difference from the first one. The first one we are told y is partly constant and partly varies, but this one is y varies partly as x and partly as x squared. So we introduce equal sign, we say kx plus ax squared. So when x is equals to 2, y is equals to 14. And when x is equals to 5, y is equals to 65. So let's say the first equation, 14 is equals to 2k plus x squared, that is 4a. Then the second equation, 65 is equals to, that is 5k plus 25a. These are the two equations. So we need to use elimination method to solve them. We need to eliminate this one. So multiply by 5 by 2. That is 5 times 14. That is 70 is equals to 5 times 2, that is 10k plus 20a. Then 2 times 65, that is 130 is equals to 2 times 5 is 10k plus 50a. So we eliminate this one. So 20a minus 50a, that is 30a. And 10k minus 10k, that is 0. So 70 minus 130, that is negative 60. So we have negative 60 is equals to 30A. Then it's negative 30 because it's 20 minus 50, that is negative 30. So divide negative 30, divide negative 30. So A is equals to 2. That's the value of A. So we need to get the value of K also. We use either of the two equations. Let's use this one. 14 is equals to 2K plus 4A. A is 2, right? 14 is equals to 2K plus 4 times 2, that is 8. This comes the other side. So 2K is equals to 14 minus 8, that is 6. Divide 2, divide 2. So K is equals to 3. So we say the equation connecting the two is y is equals to K, which is 3x plus A, which is 2x squared. So that is the equation connecting. So let's work out this question under percentage changing quantities. So the question says that given that P varies jointly as Q and R, P varies jointly as Q and R. So introduce equal sign. P is equals to KQR. When you introduce the equal sign, you introduce the constant of proportionality. So we are told Q decreases by 12%. So Q1 is equals to 100 minus 12. That is 88%. So divide by 100 will give you 0.88. Then Q1 is 0.88 Q. Then R1 is equals to 100 plus 12. That is 112. Divided by 100, that is 1.12. Then R1 is equals to 1.12 R. Then we need to get P1. P1 is equals to K Q1 R1. So P1 is equals to K. Q1 is 0.88 Q multiplied by 1.12 R. So P1 is equals to K. Then we remove Q and R outside the bracket. That will be K multiplied by Q multiplied by R. 0.88 multiplied by 1.12. We say P1 is equals to K QR into bracket 0.9856. Look at that one. Then this one, KQR is the same as P is here. KQR is the same as P. So we say P1 is equals to P 0.9856. So to get the percentage change in P, we say this percentage change is equals to P1 minus P over P multiplied by 100%. So P1 is 0.9856 P minus P over P multiplied by 100%. So you take this one minus this one, it is 0.9856 P minus P. That is the same as 0.9856 minus 1. So you get, that is 0.0144 P over P multiplied by 100%. Then P will cancel with P. This is negative, so it's negative 0.0144 multiplied by 100. That is negative 1.44%. So we conclude and say that P decreases by 1.44%. P decreases by 1.44%. That is how we work out. Last example. H varies as V and inversely as R. So I told H varies as V and inversely as R. So we introduce constant of proportionality. H is equals to KV over R. Then H, find a percentage change in H if V increases by 20%. So V1, V increases by 20%, so V is equals to 100 plus 20. That is 120 divided by 100, 1.2. So V1 is equals to 1.2 V. Then we see R. R is equals to 100 plus 50. That is 150. Then divided by 100 is 1.5. So R1 is equals to 1.5 R. So now we want to look at H1. H1 is equals to K V1 over R1. So H1 is equals to K multiplied by V1. V1 is 1.2 V over R1, 1.5 R. We say H1 is equals to, that is 1.5 over 1.2 divided by 1.5 is the same as K 12 over 15 V 12 V over 15 R. So when we cancel 3 here, 4, 3 here, 5. So H1 is equals to K into bracket 4V over 5R. Then we remove V and R outside the bracket. So we say H1 is equals to K multiplied by V over R into bracket 4 over 5. Then K V over R is the same as H. So we say H1 is equals to 4 over 5 H. So to get percentage change is equals to H1 minus H over H multiplied by 100%. That is H1, that is 4 over 5 H minus H over H multiplied by 100%. That is 4 over 5 H minus H. So there we get, that is 4 over 5 minus 1. That is negative 1 over 5. H over H multiplied by 100%. So this goes with this one. It's negative 1 over 5 multiplied by 100%. 5 here, 1, 5 here, 20. So it's negative 20%. So we say H decreases by 20%. H decreases by 20%.